Welcome, or hopefully welcome back to Reliability Matters, a podcast for the electronics assembly industry. I'm your host, Mike Conrad. In today's episode, continuing the subject of soldering materials, we'll dive deep into the science, strategy, and subtleties behind one of the most fundamental elements of electronics assembly, soldering materials. Joining me are two experts from KOKI Solder, Shantanu Joshi, Head of Customer Solutions and Operational Excellence, and Greg Starrett, General Manager of North American Operations. Together, they bring decades of experience in solder chemistry, process engineering, and real-world reliability. We'll explore how soldering materials influence long-term performance, how material and process decisions interact, and what assemblers should consider when aiming for high reliability outcomes. From surface finishes and flux residue to void mitigation and future trends in soldering formulation, this episode offers practical insights that go well beyond the datasheet. So whether you're on the factory floor, in a lab, or managing quality and reliability at scale, this conversation is for you. Let's get started.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Hi, gentlemen. Thanks for joining
Mike.
me today.
Hey, Mike.
I'm glad you're here.
Thanks for having us.
Of course.
Happy to be here. Thanks for having us.
Well, my pleasure. Ready to get into the weeds on soldering materials?
Absolutely.
Sure.
Something tells me you know something about that. So let's see if you can educate me. This is, by the way, the second in a series of episodes in soldering materials. We have a total of 3. So welcome to the middle. You're the white gooey stuff in the middle of the Oreo cookie, right? So the good stuff here. Let's talk first about material process interactions and reliability. Since this is a reliability-based podcast, it seems like a good place to start. You both have experience on both sides of the material and process sides of assembly. How important is the synergy between solder paste properties and reflow profile for ensuring reliability? And I'm just going to let anyone who wants to jump in, jump in.
Sure.
All right. I think it's critical. I think you can say that the solder paste and reflow profile are kind of two sides of the same coin. So meaning that a well-formulated paste can underperform if the profile is not adjusted or optimized correctly. So for example, if you have insufficient soap, that can lead to an incomplete flux activation, or the excessive peak temperature can maybe degrade the flux prematurely or cause more voids or weak joints. So we basically recommend like a collaborative approach. So not just saying that the solder paste is critical, but having the other factors equally optimized to basically get the best performance out of it.
Greg, are you agreeing with that, or are you ready to?
Yes,
Or are you ready
yes.
to argue with Shantanu here?
No, I think optimized synergy ensures robust solder joints, especially in high reliability applications like automotive, aerospace, where failure rates must be below 1 ppm.
Yeah, that's quite a target, isn't it?
It's definitely
Yeah.
It is.
definitely
In high-density applications, especially ultra-high-density interconnects, UHDIs, what are some of the more subtle soldering material challenges that engineers may not realize are actually reliability risks?
So when we talk about ultra high density integrations or applications, I think we can all agree that the pad spacing is very small or minimal. So even the minor flux splatters can cause some electrical leakage or dendritic growth. So one of the other things that also can be seen in the high density application is basically there can be uneven wetting on the BGA that can maybe introduce to some mechanical stresses. Voiding under QFN and BTC becomes more critical because the thermal mass has been reduced and heat dissipation is limited. I mean, there is a limitation on how much heat can dissipate in the small area that we have. So I think there is a definitely a reliability risk with the UHDI applications.
Are you finding that different or very specific materials within your offerings are more suitable for these ultra high UHDI type applications, or can any solder paste work with that?
Well, yes and no. So if you are talking about like super challenging applications where even a small leakage in the current might be harmful for the application itself, then we basically recommend what we call it as a cleanable no clean or water soluble paste, or a paste which has a very high SIR. So the surface insulation resistance, which is a very critical factor in U ultra HD applications, it's basically very critical for us when we get a requirement from a customer that, hey, our application is high density application and the requirements are 10 to the power 9, 10 to the power 11, anything like that. Then we basically have to formulate a paste a little bit differently than a standard paste, just because you know that any small leakage of the current may not be basically advisable. So
You mentioned a term in your answer. Yeah, sorry, Greg. Before we completely finish this topic here, you mentioned something, and if I don't respond to it now, I will forget. So this is the way my mind works. We're going to be like a pinball machine. We're going to be bouncing off the bumpers and kind of going all over, and then we'll come back to Greg. You mentioned the term cleanable, no clean, which I don't hear too many materials companies saying that phrase, even though no clean flux is today the most common flux being removed today, not because it needs to be necessarily because it's no clean, but because it's the most common flux being used today, period. But what makes a no clean flux more cleanable? Because the early days of no clean flux, they were notoriously difficult to clean.
yeah,
right?
super difficult to clean.
Y'all didn't think about that. Like, why would someone do it? But now that people are doing it, are you actually formulating no clean fluxes that are designed to be more easily cleaned than, say, traditional no cleans?
Yes, we are. So there is a very simple reason behind the fact that, just take an example of a CM who may be doing products for, I don't know, 80, 100 different customers. Out of those 100 customers, let's say out maybe 70 of them don't need cleaning at all. 30 of them require cleaning, or it can be 30-70, vice versa. Now, if you have two different pastes, then it's going to be super difficult for you to manage the inventory. Like, hey, I'm out of the paste, I need it tomorrow. So we basically were thinking about from the customer's perspective, like, hey, if you have one paste, if you don't need to clean it, but if you have assemblies that require cleaning, you can easily clean it. I mean, sure, with a saponifier, I'm not suggesting that they should use just straight DI, because at the end it's a no clean paste.
Yeah.
But that basically minimizes their, I would say, risk of basically having a line down, so that they only have to order one kind of paste and they can clean the products that they need to clean, and they can leave the other products that doesn't require cleaning as it is. So
Yeah, I advise customers regularly when they decide they're going to start cleaning. They say, should we change fluxes? And I'm like, no. The flux that you've chosen has been well qualified. The most important factor when one is choosing a soldering material is reflow, solder integrity, voiding, reliability, all those things. And no cleans are the most popular type of soldering material in terms of flux species. And it's probably the most engineered, most up-to-date, most supported, most understood
I
of all.
absolutely agree with you. I mean, most engineered is the correct term, I would say, just because if you look at the history of the solder paste, I don't think a lot of manufacturers have spent a lot of efforts in engineering a new water soluble paste in last
No.
5 to 7 years.
I'll bet
But if
since
you
we
look
started talking 10 minutes ago, you guys have already introduced 3 new no cleans, right? And
Exactly.
and probably
Yep.
the last OA flux that was introduced was probably in 1994 or something. I'm speaking
Correct.
facetiously, but yes. So don't change your flux just because you decided to add a cleaning process. Work around that.
Absolutely.
The
Yep.
cleaning companies, the equipment companies, the chemical companies that supply the juice that goes into the cleaning equipment. have all figured out how to clean no cleans, and with companies like yours making them even more easily cleaned, yeah, have your solder integrity number one, cleanability
Absolutely.
number two. So, Greg, sorry, I kind of cut you
Yeah.
off. We were talking about
Well, no,
UHDI and
just want to
materials.
yeah, I just wanted to kind of piggyback on what you guys are talking about here. So, we just had a call yesterday with a customer that's having an unbelievable amount of solder balls, but their cleaning strategy is completely wrong. So, we're giving them tips and pointers, and they need to use something other than alcohol to clean their stencils and make the process work better. I think that's number one. And I think, number two is using the right paste type. You're getting insufficiencies, your solder volume's not there. You got to use the appropriate type solder paste, type 5, type 6. A lot of these guys are trying to print type 4 paste through openings that require type 5 or type 6. So
Yeah.
there's many different, attributes that contribute to this to get the process dialed in.
Yeah, if I owned an EMS company, I think I would personally fund a bounty on IPA pumping stations and squeeze bottles and things like that.
Exactly.
IPA pre-saturated wipes. Everyone goes to IPA because it's just like it's like the standard, but it's a terrible solvent for these purposes,
causes more
right?
problems.
Oh yeah,
Absolutely.
it creates a white haze. It has a polarizing effect on no clean flux residues in particular. There are and it's a solvent. It's flammable and it smells. And the only positive attribute I can think of is alcohol. With alcohol or almost any solvent is it flashes off fairly quickly. It dries well, but from a VOC standpoint, from an environmental regulatory standpoint, from a safety standpoint, and from an effectiveness standpoint, it's awful. Get rid of the alcohol,
absolutely.
right? And,
Yes.
do a buyback program like you hear with, some cities want to buy back guns or something. We should buy back alcohol and put a reward on it. Any more input on the HDMI and soldering materials comments that Shantanu's made, Greg?
I just think that engineers may overlook, a lot of this and focus on larger scale defects, but, it requires a precise paste selection. So, I think it's important for these engineers to be educated on what's out there. I can't tell you how many times, I'll go into account to talk to customers about what they're using, and they're using very outdated technology. So, there's a lot of things out there that are tailored to help mitigate a lot of these issues. So due diligence, basically.
Yeah.
Do your homework.
Yeah, that's right. That's a takeaway right there. Do your homework. What's your perspective on how solder joint aging, such as intermittent intermetallic growth over time, should influence material selection or testing protocols?
So I would say like intermetallics are like double-edged sword, meaning that they are necessary for joint formation, but they'll be brittle if they are excessive. So we need to find a right balance, I would say, uh, in when you're talking about intermetallic. So I think when we talk about the aging test, like thermal cycling or high temperature storage, which are very important for the simulate or to simulate the growth trends. I mean, material choice can definitely slow down the intermetallic growth. So we have had a lot of inquiries, I would say, in last 4 to 5 years, specifically for high reliability applications, or I would say under the hood applications, if you want to call them, specifically to talk about automotive, where the customers are asking like, hey, show me the microstructure at time zero, how the microstructure evolves as a function of time and temperature. So what if you keep the same microstructure, meaning you cross section the joint, keep it in the isothermal aging, let's say 150C for 7 days, 14 days, 21 days. How are my precipitates coarsening? Is there any effect on it? Do you see more primary precipitates like growing, or how are the precipitates spread out? So on and so forth. So definitely, I would say that say that the material choice can absolutely affect the intermetallic growth. So basically, nickel modified chemistries, indium modified chemistries, uh, antimony additives. I think it basically we have been seeing that can slow down the precipitate growth. So
Yeah, you talk about aging and heat and humidity test chambers, things like that. Those are time machines. It's difficult to look into the future, but that's one way to look into the future. If you want to see what your assembly is going to be like, 10 years from now,
correct.
put it for 168 hours in a heat and humidity chamber and under a little bit of a bias, and boom, there's the future.
Yeah,
Right?
that's a good point, Mike.
Exactly.
And one of the things that we offer, and it's probably a good thing, depending on automotive, medical devices, something like that. But shear and pull testing to evaluate joint strength
Yeah.
post aging. There's it's important to look at the joint quality, but long-term reliability requires extended aging tests, to predict the field performance. So, it's just something to consider.
Can you speak to the importance of solder paste behavior during the soak zone of a reflow profile and how it impacts flux activation or residue formation? And let me preface that with a little bit of an anecdote. One of our friends in this industry, Foresight Laboratories, and Aqueous Technologies, my company, produced a DOE where we ran panels of assemblies through a reflow oven, and they were umpire 2 boards, so they were test boards for surface installation resistance testing. So they were test coupons, and we ran 4 boards at the correct minimum according to the data sheet on the solder paste. It was a SAC 305 no clean paste, and we ran the minimum peak reflow temperature on the data sheet, and then we ran some more boards 1 or 2% lower than the minimum, and then another set of boards a little bit lower, and we ranged from 100% of minimum peak reflow temperature down to 95% of minimum peak reflow temperature. And then we subjected all of those coupons to surface insulation resistance tests under heat and humidity for 168 hours under an electrical bias per the J standard, IPC J standard.
Sure.
And much to our, I have to say, to our prediction and to our amazement, because we were amazed our prediction was accurate, the SIR results got progressively worse. Each 1 or 2% we were below, that we lowered the peak reflow temperature.
Absolutely.
Because it didn't, the no clean flux didn't do what it was supposed to do because it didn't reach the right temperature. It never got their cue. It was like an actor on a stage that never got their cue. It just stood around, waiting to volatilize the activators, waiting to encapsulate the resins, encapsulate the bad actors. It didn't do as much of that. And the boards, when we got to just 5% drift in peak reflow temperature, all the boards failed. All of them failed SIR results by a significant standard. When we hit 100%, we passed all of them. When we hit 98%, we were passed, but we were like a marginal pass. Right.
Yeah.
We were above the red line, 1 times 10 to the 8th, but not by much. When we hit 3 or 4%, we were touching failure. And when we hit 5% below peak, we were miserable fail. And I just wonder how many people do the golden board test and everything is perfect. Their socks are fresh. They've brushed their teeth twice that morning. The reflow oven is perfectly calibrated. They've done all their profiles, and they test their boards and they're clean. And then they put it into production and things drift a little bit.
It doesn't work. Yep.
Yeah. So back to my original question. What's the importance, not just from a cleanliness standpoint for no cleans, but from a intermetallic standpoint and other reliability factors of the solder paste behavior during the soak zone of the reflow profile, and how does it impact reliability?
Yeah, great question, Mike, because I get this question time and again that customer is using some kind of a profile. Maybe there is no soak ramp to peak. There is pretty much, there is soak, but not a lot of soak. They don't have a stable temperature at which they keep it for 50 seconds, 80 seconds, 100 seconds, nothing like that. Just straight ramping up. So I would say, at least for our pastes, the soak zone is where the flux chemistry comes alive. So the activators basically start breaking the oxides, we say reducing the oxides. Solvents begins outgassing. If the ramp is too fast, you are going to get the flux spitting or splattering. If you are too slow, then you basically risk of oxidation or extended residue exposure. The soak zone behavior is basically tied directly to the reliability, especially to the for the no clean paste. So I think where we see the flux activation being synchronized with the soak temperatures, that's where we see the wetting and like the minimum amount of residues. So for example, let's say think about it as a standard profile between 130 to 180 for 60 to 100 seconds, standard soak temperatures. Then we say a second ramp up, we should reduce like between 180 to 220, less than 30 seconds, because there is not a lot of help with the paste at that temperature. Most of the stuff has already been reduced and oxides have been taken care of. And now if you basically put your assemblies for a long time between 180 to 220, it's going to be a lot of outgassing and you will see more voiding. So it's not just about the soak, but it's also about the ramp up time, the soak, the second ramp up, the peak, and basically the TAL. Everything basically needs to come together and have a have a great optimized reflow profile for that assembly. So you bring up a great point about having a golden board. I think these days it's because of the shortage of the component, shortage of the boards, may not be always easy to have like one assembly, basically like completed assembly, and then basically you're drilling from the bottom and putting the thermocouples down there and running that board maybe every 2 weeks, every week, every other day, depending on how many boards you are running. So what we recommend is basically doing a product families. So if you have like a product families, meaning the design is a little bit different, the amount of copper, number of components on the board is not very different, then you can basically do like different product families if you are not able to dedicate one golden board for each product. And then you would highly recommend you to run that maybe every week, every other day, depending on how you feel comfortable, and basically see what's the temperature, actual temperature on the board underneath the QFN, underneath the BG. Are you going to get enough heat there? Because typically when you are doing the profile, you are basically running one board, and when you are doing a mass production, the oven is full. So you have to take into consideration all those factors and make sure that those boards which are coming out of the oven when the oven is full are not gonna basically see a less temperature than the other board that was profiled when the oven was empty. So
I think we may have inadvertently just sold a whole bunch of oven profilers. It does seem like a good investment from this perspective. Greg, anything to add?
No, it's funny, Mike, because this morning I had a call and we have a customer that has a 13 zone Heller oven and they never do profiling on this. So we actually shipped them one of our profilers and walked through the process with him. And he just was so stoked that we were able to sit down and help him with that, with that process. But, if if you don't have the right soak, you're not activating the flux the right way, right? So there's a lot of risk that, long soak, you're depleting the flux activity, which leads to oxidation or excessive residue. And, we get calls all the time. Well, why is it like this? Well, did you profile it the right way? And it's, time and time again, it's just, I don't know if it's laziness or just too busy, but it's all part of the process. And you need to.
I think a lot of it is, and I'll say this word, but it sounds like a bad word, but a little bit is ignorance. And I don't mean that as trying to victimize, someone. It
Right.
If I buy solder paste, it comes in a jar. I follow the directions. I put it in an oven. I expect it to come out, it hits a temperature, it reflows at a certain temperature. That's just, a question of what alloy you're using. That's just physics, chemistry. It comes out the other side and voila. But there's a whole science, maybe even a black art behind, how all these things have to work. And it has to be kind of a perfect storm of correct events in a certain order for a certain time at a certain temperature. And all that changes based on the complexity of the assembly and the density of the heat sinks and all these thermal things that go on. And then every oven's a little bit different. Some ovens are 7 zones, some are 3, some are just like literally ovens, without a conveyor, batch ovens. And then you have all these very sophisticated machines. And so there's so many variables that go into the recipe. It's not just follow this recipe and it works for everybody. So that puts a lot of challenges, I think, on companies like yours and others to have as much instruction as one can provide, knowing there are, 20 different other variables that you have no control over.
Right.
And everyone's a little bit different. There's probably, millions of combinations when you look at all the different ovens, all the different types of ovens, brands of ovens, and materials and ambient conditions and user proficiency levels and all these things that get into the soup. So no one recipe is exactly the same, even on the same product, on the same brand of oven, on a different production line, right? It could be a little bit different.
And that's what we like to do. We want to educate our customers, and we want them to follow our process and understand why we're recommending, giving them ideas on what to do to fine tune their process. So as you mentioned, it is a science, and you have to do your homework and do some due diligence and understand the process to make it run perfectly. Or it's never going to be perfect, but, get it to an optimal setting.
Yeah.
Mike, just to like to bring up a small story. So had a customer, 2 identical ovens. Okay. So one line, the product used to run absolutely fine. On the second line, it never ran great. So the question I had was, have you calibrated your oven? And the answer was no. I was like, that's the problem. So it's not about the
Bingo.
profile always. Sometimes you need to make sure that the oven is blowing the hot air at the correct speed. The fan speeds are very critical. You need to understand that you need to take some time out of your busy schedule, do some PMs on the oven. Sometimes you are running products which are with the thick stencils and the flux is up there. I mean, you need to basically vent it out, clean it up, and then it's gonna basically have the same features when you bought the oven in the first place. So
Yeah, well, IPC and under the J standard 001J, section 8, which is all about cleaning, there are you have to do a validation test first to generate objective evidence, and then you have to do process monitoring through 2 different protocols. But you only have to do the validation test or the qualification test one time, unless something changes, and they have what they consider level 1 changes, level 2 changes. Each require a varying degree of requalification or revalidation. And one of the level 2 changes is if you just move your oven or your production line from one side of the building to another. Same equipment, same operators, same materials, level 2 change. It triggers a little, a smaller degree of requalification or revalidation. But nonetheless, you kind of have to go back to some part of the drawing board and prove that nothing changed. Just moving a machine 6 feet technically triggers a change, right?
The air draft can play a so significant role in making the reflow oven so dramatically different. So that's the reason why if you move, requalify. I mean, I know it's a painful process, but it's designed to make sure that the product which is coming out is going to be fail-proof. So,
well, definitely a painful process, but slightly less painful than a recall and RMAs, right?
exactly.
And
Exactly.
damage to reputation and things like that. It's
Right.
preventative maintenance. When it comes to solderability testing, do you believe that the current industry standards adequately reflect real-world conditions? You were talking about shear testing, pull testing earlier. If not, what improvements would you recommend? If this was Shantanu and Greg's world, and you were the co-kings of the industry, would you make any recommended changes to solderability testing?
So
But
I would, yeah, go ahead, Greg.
no, I was just the first thing that kind of what we were just talking about was the environment. So environmental factors like humidity or temperature fluctuations, you know, incorporating humidity and contamination in test conditions. Shanta, we just had a conversation yesterday, and it was kind of refreshing because, we sent a sample out to a customer and he asked, like, what should the humidity be in his building, which you don't often get that. So I think that's super important. It's just one thing I wanted to touch on was the humidity and temperature.
Yeah, which can vary within a facility. And certainly if you
Absolutely.
open a second facility, if you decide to build boards in another country that might be more humid than this country, or the country of, where you're doing the work, everything changes, right? Everything
Yep.
changes, including
So-
where the material's been stored and how long it's been stored and
Right.
where it was made and how long it was on a ship and things like that. That all, you're importing environmental conditions into your process. It's not just your ambient conditions around. It's the condition and the exposure over time of all the materials that are put into the soup, right?
Right. So I would say that the current solderability standards somehow lack in replicating the harsh production environments. As you said, after COVID, basically after the we had a part shortage, we tend to see a lot of parts getting or having some kind of oxidation or irregular plating, or it's not uniformly plated. You can say like poor handling, contamination. There are 100 different things that might have gone wrong with the components. So we somehow, again, I shouldn't just put it out there that the standards doesn't do anything. I mean, they are there for a reason, but I don't know how we can incorporate these conditions into basically making a standard more robust, meaning uh, like testing on a very like deliberately oxidized parts, testing on a parts which are contaminated with some foreign material, testing on a part which is bad plated parts. I mean, you're gonna get that. So the first thing that we typically hear from the customers that, hey, the solder paste is bad, or the reflow profile was bad, or this is bad, or that is bad. But we need to understand, like, we need to solve this issue together. We need to go to the bottom
Right.
of this and find out the root cause, why it is bad, or why our process couldn't handle that in the first place. So the other thing that it's on my wish list is basically doing an SIR post reflow on realistic board geometries. Right now we do the SIR on pretty much test coupons, right? So, but it doesn't really transition into like uh, how the boards have been shipped. Like if you have like an ADAS products, they are never going to look like a test coupon. They are going to look like an ADAS board. So we
Right.
have to make sure that the residues which are on the board are qualified according to the high SIR standards that you need, not just the test coupons. I mean, absolutely agree. And again, I'm really sorry. I shouldn't put like, hey, I need this, but I don't have a solution. But I want to brainstorm with you guys and basically, hopefully, somehow the industry can come together and do a standard where we are not only testing on the test coupon. And I get it why we need test coupons, because it can be standardized and everyone can do that.
Well,
But
yeah, and
then
you
every
can't.
application
It's
is
hard to take
different.
an
So
ADAS board, for example, or any assembly, and almost no assemblies are candidates for SIR testing because that requires
exactly.
particular
Yep.
comb patterns and contacts and usually edge connectors and maybe it's time for assemblers to build out a breakaway test coupon on their production board, right?
Correct.
So that all you do is snap it off and throw it away or test it. And at least that board goes through the same process, and it's made by the same fabricator and
Right.
went through the
Exactly.
same pick and place machine and went through the same
Same.
printer and oven and
Right.
all that. But the
Exactly.
closest thing we can come up with is a facsimile. And we can put this similar soldering materials and similar dummy components, because a lot of the components are too expensive to waste on that.
Exactly.
But it's never going to be 100%. It's never going to be near 100%. It's going to
Sure.
be kind of like, but it's not a substitute for an actual real assembly. It's just it can't be unless they incorporate SIR breakaway coupons within the actual real
The
assembly,
actual-
which I think
right.
is a wise move. Let's talk a little bit about material characteristics and failure prevention. How can engineers better evaluate that their soldering materials won't contribute to electrochemical migration in the field? That's a big thing right now. We've always had
Yeah, it
ECM.
is.
ECM has been here since the beginning of electronics, but it's more prevalent today because the distance a dendrite has to grow is far less. It can basically
Yes.
just roll out of bed in the morning, reach its arm, and touch the other conductor. Right? It doesn't have to go far. So the tolerance for residues on modern circuit assemblies is far lower than they were just 5 or 10 years ago.
Absolutely.
So how can engineers better evaluate the materials that they're buying from solder paste perspective, flux perspective, with that in mind?
I would say basically start looking for fluxes with high SIR and low ionic contamination. That would be the good start. Beyond that, I think testing is the key. I think testing is gonna tell you more than what you basically can see on the paper, because the manufacturers or the suppliers can tell you 100 different things, but if it doesn't work for your application with your process challenges or process abilities that you have, it's not going to be helpful. So I would say, like, beyond that, I mean, you have to look at the SIR under bias and humidity. We call it like a dewing test. So we are not only changing the temperature, but we are also changing the humidity as well when we are doing the thermal cycling. So the board is going from, let's say, minus 30 to 80, but at the same time the RH is going from, let's say, 20 to 90, and it's also doing the cycle. So something of that nature where you are deliberately condensing the board, which is obviously under bias, and you are giving them more inputs that, hey, please fail now. So you are testing it under extreme conditions just to see like how it will uh, like correlate to the actual service conditions that the board might see.
Yeah. Greg, anything
Yeah, I
to add
agree with
there?
that. Yeah, just kind of simulate the field conditions, right? Test the assemblies with realistic contamination. You don't know who's touching what, right? So there's fingerprints, dust, conformal coating interactions. There's a lot of variables, and there's a lot of different people that are part of that process. So I think, simulating those conditions is important.
What role does flux chemistry play in reducing voiding beyond just thermal profile adjustments? Are there key indicators that make paste inherently more void prone or void resistant? And I say that because a lot of solder companies, soldering material companies, have solder paste and low voiding solder paste, which I always ask, like, is there a high voiding solder paste? I've never seen that on a shelf before, right? I assume all solder pastes are
Right.
low voiding, but clearly, while there is debate over what really is acceptable voiding, I've heard people say you can have 20% coverage, you can have 80% voiding, and you're fine as long as the thermal management side's, it's not coming off. And I've heard 70%, I've heard 90% coverage is required. There is a standard, but I don't think there's a general agreement that whatever the voiding percentage, allowable voiding percentage, should be. In spite of all that, what are the or how does the choice of a soldering material land for those who are concerned about voiding? What types of decisions should they make, and what types of materials are better at avoiding voiding than others?
Okay, so great question, Mike. So obviously, no one is gonna market their paste as high voiding paste because there is no such thing as high wording or low wording. It's all relative, right? So typically when we talk about solder paste, it's always a fine balance between what you need and what you're going to get. So sometimes the customers want powerful wetting, sometimes they need high SIR, sometimes they need both of them, sometimes they need in circuit testing compatible residues, sometimes they need anti head and pillow ability, that the solder paste can stay active for a long time so that the BGS can basically merge into the paste and form a homogeneous joint. So it's not really that you're going to get everything in one solder paste, and now you want a true halogen free solder paste. So it's there are a lot of factors that can come in, but typically when we talk about the flux formulation, we talk about the volatiles, because there are some fluxes which basically have volatiles that may uh, outgas too much. Some of them have low volatiles, which basically means that the paste is a little bit too thick. So it can have a lot of different consequences based on how the chemistry is designed. So as you know, in the solder paste, you have resins, you have rosins, you have activators, you have thixotropic agents, you have volatiles. So a fine mixture or the balance between these ingredients will basically make or break a good solder paste. So uh, I would say, like, it's not something like one ingredient is going to have a totally different effect than the other. I think is the combination of all of them coming together and having a uh, having a low voiding solder paste. So typically when we talk about low voiding solder paste, we want to see the solder paste basically where the flux basically outgas a little bit less. There is not a lot of volatiles which are outgassing and causing a lot of gases, which will be difficult to basically remove before the solder base solidifies. So that's what I think is important in a good solder paste as far as voiding is concerned.
Greg, anything to add there?
Yeah, I think the activator strength is important too, right? So overly aggressive activators can cause excessive outgassing, increasing the voids that Shantanu he mentioned. So high indicators of void are prone to pastes that have high solvent content, poor slump resistance, or mismatched flux and activity for the alloy. So, fortunately we have a way to do a lot of testing internally to look at voiding and look at outgassing. So we have the tools to kind of test this before we put it out to the market. So it's really important. I think most customers, and Shantanu, correct me if I'm wrong, but I think most of our customers want to get down to 15% voiding, and
Lower, yep.
there's or lower, and it's there's a lot of variables that factor into that. So I think in my experience, in my short time with KOKI, I recognize, some of the products that we have that, there's new formulations out there. And again, it kind of goes back to what I was saying earlier. Like, some of our customers are using very outdated solder paste where, there are lower voiding pastes that are available on the market today.
Maslow once said that if all you have is a hammer, all you see are nails, right? So you guys have the hammer. In your case, the hammer is you're a soldering materials company. So you're going to see every solution as better soldering materials, right? I'm in the cleaning industry. I see everything as it's either clean or dirty, right? But what are some of the biggest opportunities you've seen for improving soldering reliability through better process control, not just better materials? So take the material out of it. Let's assume they're running a good material. What's the largest opportunity to improve reliability through, other than just through changing materials?
So I would say the solder paste inspection data utilization, I would say that as maybe number one, because you can see a lot of different things in the SPI data. So whether you are just looking to see whether it's a pass or fail, or are you seeing any trend where the solder paste transfer efficiency is slowly reducing, or are you seeing any shifts? you can basically, these days, I'm sure you have seen this, that the SPI can talk to the printer or the pick and place and can make adjustments on the fly. So these days, I think because of the AI, or you can say IoT, whatever, you basically can use the data in a proactive way, so that the operators are not have to sit down in front of their computers, crunch the numbers of the SPI. The computer can do it on the fly. So I would say that the SPI data utilization is probably, I would say, I would rank number one. If I have to guess the second one, I would say the stencil inspection. I think people absolutely should do a real time stencil inspection. They shouldn't believe that the stencil is basically exactly how they saw the check plot yesterday. They acknowledged it, everything looks good. Absolutely make sure that the stencil is in exactly how it should be. And I mean, I shouldn't talk more about stencils. We have Greg here. He has an immense background of stencils. I'll let him talk about the stencil inspection. So,
So, for me, yeah, for me, the SPI machine is critical to the process. And there's many companies out there that don't have it and just can't afford it, or they want to spend their money somewhere else. But that's a catch-all. It's gonna flag insufficiencies, and then you're gonna look at the stencil. Or, for me, the printer support is key to a good print. Squeegee speed, squeegee pressure, cleaning, Mike. Like, the solvents that you're using to clean. Are you wet wiping? Are you dry wiping? Like, what's the frequency? All this plays a factor. So it's so process dependent for many companies. And you know it it's each company has different processes, right? But if they get all of this dialed in, they're going to get a good print. We just have to convince them that these are the steps that you need to take. It's not like we're just going to throw a stencil on there. We don't look at area ratios. We just print, and we want our print to look the best. It's not real. You want your print to look the best. You got to check the boxes along the way.
Yeah, I interviewed some manufacturers. We had a panel of competitor manufacturers that made AOI and SPI X-ray equipment. And I asked them, if you only had enough money to buy one, AOI or SPI, which would you buy? And everyone was SPI. Because SPI stops things from getting into the oven. AOI stops things from getting into the UPS box. And if you can only afford to fix one, rather than having to rework an assembly, or worse yet, throw it away, we can avoid that. Now, SPI won't catch, wrong polarities,
of course, yep,
put down by things. But I think the reliability is most impacted. Pretty much the life of a reliable circuit assembly begins at the print. And I'm sure the oven people go, no. It begins at the reflow. And the cleaning people, we all think it begins at cleaning. But we all have our own preferred genesis of reliability. But I do really think that it does begin at the print.
Right.
And the print has so many variables to it. So, you guys make a product that is designed to perform a particular function, but you don't have a lot of control over how that product is used and the environment that it's used in. Have you seen instances where a seemingly minor tweak, like a stencil underside cleaning frequency or ambient humidity control, made a significant impact on reliability?
Huge, absolutely. I think I would say that a funny story actually. So, one of our customers was doing a pin and paste, and typically we say that don't do two prints, right? I mean, you're gonna smear it. So when I told him, like, you're doing pin and paste, just do two print. The first print is gonna get squeezed in, and you're gonna get a full barrel fill. He was looking at me like, what are you talking about? And I was like, just do it, man. Try it. And it worked wonders. So
Trust me.
So it's something like that. I mean, it's not like I know everything. You are just gonna learn every day something new. I mean, no one knows everything. If they say that I know everything, I think they're lying to themselves. But it's all about taking the cues. One of the other stories I would like to share is We had a customer where we still have the customer. So they used to do like stadium lightings, like metal core boards, heavy boards. And I was thinking to myself, like, hey, can we change the bottom zones a little bit hotter than the top zones so you can actually feel like you're soldering on a hot plate? Because thankfully it was a single sided assembly, just LEDs. And by any reason you were not able to tweak in the profile exactly how I wanted it. So I bumped the like bottom zones 5 degrees hotter than the top zones, and it worked like a charm. So simple things like that. I mean, it just feels so great to look at the finished product after it. Something worked out, but
It
I
just
mean,
goes
I'm
to
sure
show
I have
how
100 different. Yeah.
Yeah, it just goes to show how much of our industry still thrives on tribal knowledge, and
Yes.
you won't find that on a product bulletin, right?
Nope.
That's something that's passed down kind of from generation to generation of technician or engineer, and
Pretty
it
much.
probably doesn't make it to any standard either. It's just something you kind of got to know. Back in my
Right.
early days, I started in this industry in 1985, and one of my early things that I used to sell were vapor degreasers. Back in the day when we had vapor degreasers,
Uh-huh.
which we still do today, but back then they were running on trichloroethane or Freon TMS. And we had an issue where someone had bought a machine. They bought some brand new Freon TMS from DuPont. They filled it up, and they were getting white residue, like this haze. And we couldn't figure out why. And we thought, okay, well, change the batch of Freon. Back then it was cheap. Change the batch of Freon. Maybe it's just a bad batch or something was contaminated in the tank. So they put fresh Freon in it, cleaned out the tank, put fresh Freon in it, and same problem. And I was baffled. So I called DuPont, and it's not like Bob, the engineer, answers the phone. You go through, miles of red tape. And I
Of
finally got
course.
this old guy, and I only say that because he mentioned to me in conversation that he was this was his last week. He was retiring after like 60 years or something at DuPont, and I
Wow.
told him the problem that our customer was having. He goes, "Oh yeah, just it's too fresh. It needs to be loaded a little bit. Have him take about a cup of RMA flux and pour it in the vapor degreaser." I'm like, you're saying to contaminate it? I thought, he goes, yeah, try it. Like a champ, like
Solve
a
the
charm.
problem. Yep.
Totally solved the problem. It just needed a little bit of loading. It was almost too fresh. So
Yep.
I'm sure he understood the chemical reaction to it, but he didn't
Of
bother
course.
explaining that to me because it would have been lost on me. He just said, just throw a little flux in there and put a little flux in it. So, you change your chemical, you clean out your machine, you fill it up with this brand new pure virgin material, and then you throw a little flux in it. To your point,
That's
yes,
Cool.
awesome.
it's very, very
Yep.
tribal. Finally, last question. We're about out of time. From your perspectives in both research and operations, what do you think is the most misunderstood aspect of soldering reliability today, and how should the industry address it?
Wow, big question. So I would say that most of the people feel like they can solve their issue by changing to a high reliability solder alloy. So not necessary that's going to be the case always. I think we have to understand the application, the requirements, and where the application needs to be functionable in the service environment. We need to understand all of that and then basically make a product which is robust, not just the solder joint but also the everything what is associated with it. I think that's I would say that would be something that I would look forward to. So
Yeah.
Craig?
And for me, there's several things that some of them we've touched on already, but just kind of going to reiterate them anyway. But enhance the testing, adopt stricter SIR and standards for different types of residues, educate engineers, train them, train the younger guys, knowledge is power to me. So a lot of these guys that have been in the industry that are, getting closer to retirement age, teach the next generation of tips and tricks. And, like you mentioned, your your flux trick. Always share, make the industry better. For us, develop better fluxes. And I think that's one of the things that we continue to do. We're always coming out with new formulations, and, for the companies that are out there that haven't changed, formulations in forever, take a look at new things that are available on the market. I think you'll be pleasantly surprised. And that's pretty much it.
I think 3 more products just came out from your research lab since the beginning of this broadcast here. So I think the dings I kept hearing were probably new product announcements. Someone's ringing the bell every time a new product announcement comes out. Shantanu and Greg, thank you so much for being my guest today and sharing your knowledge, your deep knowledge.
Pleasure is ours.
On soldering materials, and not just soldering materials, but process that makes soldering materials work. Because you guys got to solve a lot of problems that you never created. So I totally respect that and appreciate the work that you guys do. And for my audience, if you're watching this podcast on YouTube, just look down here somewhere where it says see more, and you'll see information on KOKI Solder and how to get a hold of my guests so that you can challenge them with process-related questions. Maybe there's some tribal knowledge there for you. If you're listening to this on your podcast app, when it's safe to do so, when you get to your destination, go to your podcast app, look at the show notes, and all that information will be there as well. Gentlemen, thank you so much for being my guests.
Thanks,
Mike. Today. Mike. I really appreciate it, and I look forward to seeing you guys in person sometime soon.
Absolutely.
Appreciate you. Thanks, Mike.
And that's a wrap on another episode of Reliability Matters. Thanks for hanging out. Whether you listened to it on your favorite podcast app or watched it on YouTube, I really appreciate you being here. If you haven't already, hit that subscribe button so you don't miss future episodes. On YouTube, give it a thumbs up and subscribe so you'll know when new episodes go live. New episodes drop every second and fourth Tuesday of the month, so mark your calendars. A big thanks to PCB Chat from the Printed Circuit Engineering Association at PCBchat.com and Ascendo Reliability at reliability.fm for syndicating the show. Got a question or an idea for a future episode? I'd love to hear from you. Just shoot me an email at mike@mikeconrad.com. Just remember that's Conrad spelled with a K. Want to learn more about the podcast? Head over to reliabilitymatterspodcast.com. Thanks again for being here. Until next time, keep learning, keep doing it right, and remember, reliability matters. I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.